Well, good evening. All right, this is the Laugh at Mr. Gunn lesson, I'm afraid. This is lesson 9-7. We're going to be talking about 3D figures and spatial reasoning. And I'm going to do an okay job, I think, of conveying the basic principles here. But there is going to be a catch in that while I'm drawing these objects, these are three-dimensional objects. So I'm, by definition, drawing them on a flat screen. And so what we're going to be doing is drawing, at best, optical illusions to convey the idea of three-dimensional objects. That said, this is where our artistic abilities tend to get a little stretched. So I'm going to teach you some principles that will help you to draw things accurately. I'm going to teach you some vocabulary as well. So let's get started. Let's talk about drawing 3D figures. Okay, and one of the principal ways to draw a 3D figure is to start with a front face. Like, let's say we'll start with a little cube here, or a little square, and then to draw an offset version of that same shape. So basically it's just a translation where we've slidden this exact same shape up and to the right. And then what I do is I connect the corners. And the ones that are going to be visible, I'm going to go ahead and darken in. Oh, excuse me. And the ones that are in the background, I'm going to make dotted lines. And so that is, I mean, if you really look at it, all that is two overlapping squares with a couple lines connecting them. Okay, that is actually a two-dimensional object. All right, now it conveys the idea of a three-dimensional box or ice cube. Okay, and that's the main idea for this lesson. So don't worry if you can't draw perfectly. Just try to use the principles, and you'll be able to draw pretty accurate things. So we'll all know what we're talking about. All right, let's talk about a little vocabulary here. When you make a three-dimensional polyhedron, which is kind of like a three-dimensional polygon, the flat sides that are shapes that are polygons themselves are called faces. Okay, the places where faces come together are called edges. Okay, and the corner points that are just like the points in a polygon are called the vertices. Okay, just like they were in polygons. Okay, so polygons had vertices and edges. Now we have also faces. Okay, and by the way, it goes without saying that the object that I just drew for you is a three-dimensional square, also known as a cube. All right, let's continue on. Let's talk about naming 3D figures. Okay, basically there's two categories. We'll separate them right here with the middle of the screen of 3D figures. Now there's other special ones, but the main two categories of 3D figures are the cylindric solids, okay, and the conic solids. Now you might be thinking cylindric sounds an awful lot like cylinder. Okay, and you're right. And when you draw a cylinder, what we usually do is we actually draw it like we're standing back away from it, like a Pringles can standing up. And then we draw a shape like this, and we make it kind of curve to the bottom, and again, we can make the dotted in the back. Okay. Now, if you look straight down on it, you'd see a circle. Okay, but since we're looking at it kind of back from an angle, we're actually going to draw the bases as ovals or ellipses. Okay, so this is a cylindric surface, a cylinder. But there's also a prism. Okay, and in a prism, this is also considered a cylindric surface, and basically instead of starting with a circle, we're going to start with a polygon. Okay, so that's a rectangular prism. I can also have these laying down, so I'm going to make this one right here. Looks like a tent, or kind of that kind of prism that you hold up to the light to make the rainbows. Okay, so both of these guys are prisms. And what we do with prisms and cylinders is we take one polygon or a figure and we basically just lift it straight up. Okay, now conics are things, and so all of these are called cylindric surfaces. Conic surfaces are the ones that come to a point. So again, you're probably thinking of the word cone. And sure enough, you're right. A cone is a conic surface. Okay, but so is a pyramid. So let's draw a Pyrmad, P-Y-R-M-A-D. And let's, whoa, that's not even close. Let me try that again. Let's see, Pyramid. There we go. And let's draw an interesting one. Let's draw a hexagonal pyramid. So we're going to start with a base that's going to look kind of like this. And again, we're going to kind of make it kind of squished. And I'm not going to try to make dotted lines. It's going to be a little bit too complicated to do that. So I'm going to go ahead and I'm going to draw from a vertex point down to all of these sides. And you can kind of picture a five-sided teepee, okay? And that's a pyramid. Okay, so pyramids and cones are both conic surfaces. Now I'm going to draw a third category down here because we also have things like balls, which we call spheres. And the way to make a ball or a circle look three-dimensional is just draw a circle and then kind of put an equator on it. Okay, and then we have other surfaces. There's one that's very famous. It's called the torus. You'll probably recognize it better as a donut. Okay, and that's a mathematical object as well. And so that's the deal. Now, with prisms and pyramids, we name them based on what kind of base they have. So if we have a prism that starts with a triangle that goes straight up, we have a triangular prism. If it starts with a rectangle, we have a rectangular prism, and so on. Same thing with the pyramid. So when we drew a pentagon and go up to a point, that would be a pentagonal pyramid. The pyramids in Egypt start with squares, and they go up to a point, so those would be square pyramids, and so on. The pyramid that I have sitting in my room that's made out of the wiffle balls and the sticks is a triangular pyramid. Okay? So that's naming 3D figures. All right, let's continue on. One of my favorite things that you can study when you're looking at polyhedrons is you can study Eulers Formula. So let's go ahead and quickly sketch a cube. And again, you don't have to spend a lot of time on it. You can make it pretty rough, but you can convey the idea of a cube here. Let me fix that one side in the back. All right, now Eulers Formula talks about the definitions that we had on the very first page. Okay, on the first page, remember we have vertices. Those are the points. Okay, once again, we've got edges. Those are the sides. Okay, and then we have faces. Okay, and it turns out that in any polyhedron, any three-dimensional polygon, if I take the number of vertices, okay, and I subtract the number of edges, and I add the number of faces, it always comes out to be the magic number 2. Let's try it right now for the cube. Okay, the faces of a cube are pretty easy. Obviously, cubes are what we make dice out of, and so there are 6 sides on a die, so there are 6 faces on the cube. The vertices are pretty easy too. The vertices, if you look around the top, you'll notice that there are 4 corners, and then if you go down the bottom, there are also 4 corners, so there's a total of 8 vertices. Now the edges are a little trickier. The edges, you'll notice you've got 4 going around the top, and you got 4 going around the bottom. But you also have 4 going vertically connecting the top to the bottom. So there's a total of 12 edges. Now, remember we're going to add the yellow ones together. So 8 plus 6 is 14. And then we're going to subtract 12. And sure enough, 14 minus 12 is 2. Let's try it again. Let's try it on the tetrahedron that sits in the base of my classroom on the floor. And I think you'll notice here, I'll do this one in red, there are 4 faces, there are a total of 6 edges, and, there are 4 vertices, there are 6 edges, and there's 4 faces. 4 plus 4, the top and bottom is 8, 8 minus 6 equals 2. And we'll practice this with a lot of the weird polyhedrons that I have around my classroom, in particular the icosahedrons that there's one that hangs from the roof, and there's also one that sits up by my desk. Okay, so when you're asked to identify three-dimensional objects, remember what I said about prisms and pyramids, that we name them for their bases. And then just remember this basic idea. If you start with circles, you're going to go up. If it goes straight up, it's a cylinder. If it goes to a point, it's a cone. Okay, and then also we have a sphere. And you don't need to worry about the donut thing, but I'm going to just tell you quickly, it's called a torus. It's spelled T-O-R-U-S. It's not spelled like the bowl or the car. It's spelled like that. And let me go ahead and fill this one in. This is a sphere right here. All right, well, thanks for tuning in. That's pretty much all I have for you today. So we'll practice this stuff tomorrow in class, and we'll also practice a little bit more of how to actually draw these objects. Okay, so thanks for tuning in. We'll see you tomorrow.